Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate. We're going to look at the g of x function now. Remember, this is in vertex form. Now, this looks a little bit different than what we've seen here, but it is still vertex form. And again, how do I know this? Because it's a quantity squared. Okay. So let's identify what our a, our h, and our k are. So remember, a is the leading coefficient or the number in front of the parentheses. So in this case of g of x, it's just 1, positive 1. H is on the inside. So remember, if it's x minus h on the inside, then the h value used is positive. If it's x plus h on the inside, then the x value used is negative. So inside here I can see it's minus 1, which means my h value is positive 1. And k, it's plus k, but there's nothing here. So we can think of this as plus 0. So let's go from there. With vertex form, we can know the concavity and the vertex. So let's start with concavity. Since my a value is positive, it's more than 0, I know it's concave up. And my vertex is going to be my h and my k value brought together. So I can see it's going to be 1, 0. And I can see now that's going to be an x-intercept. So remember in the previous one, if I know the vertex, then I know the axis of symmetry. So the axis of symmetry is found by the x-coordinate. Now I'm going to go to my Desmos and I'm going to graph it to get other characteristics and values. So it's concave up like we thought. It's definitely very wide. Some of these values here, that's interesting. Okay. So here is my x-intercept and there's my y-intercept. So y-intercept is 0, 1, and notice my vertex is the same exact thing as my x-intercept. That can happen. So let's turn that off. What else do we need to know? Let's see, we have intercepts. Domain and range. Okay, so what's the domain of this? Again, with any quadratic, the domain is always all real numbers because there's no number you can put in that'll restrict it. You can put in positives, negatives, you can put in decimals, 0, and everything exists. Range. Now, this has it's opening up, so it has a minimum value. So that minimum is going to be the lowest part of our range. So the lowest it goes, the lowest y value is 0. Now, what is the largest y value? Well, do you see how the graph continues to grow up in a positive infinity direction? That's going to be my range. So looking at my list up here, I can see the last thing I need to do is increasing. In this particular case, so again, remember we read left to right. So in this particular case, I can see when I read left to right, when I start on negative infinity, I can see my function is decreasing right here. Okay, so as it's decreasing right here, okay, it's going to keep going from negative infinity up until my vertex, which is positive, the x-coordinate, which is positive 1. So it's decreasing from negative infinity until positive 1. Now, after it starts from positive 1, then it starts to increase again, and it'll keep going as my x values approach positive infinity. All right, and there.